Ray Allen makes 90% of his free throw foul shots. Suppose he takes 3 free throw shots. What is the probability he makes all of them? What is the probability he misses all of them? What is the probability he makes 1 of them? What is the probability he makes 2 of them? So what is the probability he makes all of them? Well, first of all, what is the binomial random variable here? What is x representing? That represents the number of successes in 3 trials. So in this case, the number of shots he makes out of 3. So how does this binomial model behave? We need a number of trials and we need a probability of success. These are the 2 parameters which dictate and tell the binomial distribution what to do. They are 3 and 0.9. He's going to take 3 shots, that's 3 trials. And there's a 90% chance of success on each trial. So what does this mean? It means that each time he takes a shot, he has a 90% chance of success. So what we want to find in this problem is the probability that x equals 3. We want him to take 3 shots and want all 3 to go in. We want to figure out what is the probability of that. Okay, so what we can use here is the binomial distribution formula to figure out the probability that x equals 3. Again, we have 3 trials and we have 0.9 probability of success on each trial. When you substitute in, you get 0.729. So there's a 73% chance. So basically, almost 3/4 of the time that Ray Allen has taken 3 free throws, assuming the binomial model is a good model for this situation, 3/4 of the time he's made all 3 of those free throws. What is the probability he makes 2 of them? Well, in this case, we're simply going to substitute 2 instead of 3, and now we get 0.243 as our answer. What is the probability he makes 1 of them? Now instead of substituting 2, we're going to substitute 1 because we want to figure out the probability of the random variable x equaling 1. And then we get 0.027, and then what is the probability he misses all of them? Not going to happen very frequently, right? 1 in 1,000 times, 0.001. So let's look at one more example here. Danny makes 15% of his free throw shots, and let's say he takes 5 free throws. What is the probability he makes all of them? What is the probability he makes 4 of them? What is the probability he makes 3 of them? What is the probability he makes 2 of them? What is the probability he makes 1 of them? What is the probability he makes none of them? So I make 15%, or he makes 15% of his shots, and let's say he shoots 5. What is the probability he makes them all? So what is the binomial random variable? That's the number of shots made not out of 2, not out of 3, it's out of 5. How does this behave? Well, on each trial we have 15% chance of success. So we have 5 trials and 0.15 as our p. So what does this mean? Well, we have 5 trials, and on each one of these individual trials, it's not a 90% chance of success like with Ray Allen, it's a 15% chance of success. So what is the probability he makes all 5? What is the probability he makes 4? What is the probability he makes 3? What is the probability of 2? 1? 0? All of this stuff is contained right in the binomial distribution table. It's right in there. What you want to do is go to where we see n equals 5. That's right here. And we want to go to n equals 5 and p of 0.15. So we have a number of trials is 5, and we have 15% chance of success on each trial. So what we can do is look up each of these probabilities that we're interested in knowing about. Here is the probability distribution.